Okay, so I'm going to walk you through the review solutions, and starting with partner A, we wanted to find what is the probability that a manager went to a public college. So probability of public college. So since we're only talking about managers, I don't have to specify. So public, and that's going to be the number of ways that how many went to college. And if you look at that, this right here is the marginal distribution for college. For college. Okay. So how many are there? There's 1769 that went to a public college. So I'm going to put 1769 over the grand total of 3265, which is right over here. Okay. So 3265. And when I get my calculator and punch that all in, I get 0.542 after some rounding. Okay. Now we'll go over to partner B, which is on the other side. What is the probability that a manager is at a high level? So here, we're just looking at, we're not worried about public or private colleges. We only care about high, medium, or low. So we're interested in this marginal distribution for management level. Okay. And that will be all of this piece right here. Okay, so that's the marginal distribution for management level. And we want high. What is the probability of managers high? So we're not worried about the college level. I mean, the type of college. And how many are high? 182. And in this case, the grand total is 3265, which is really the same because it's the same table on both sides. And when I punch that in the calculator, I get 0.056. So that's how we do those first two problems. We're looking for public college, so I looked at the marginal distribution for colleges. And then we were looking at high level, so I looked at the marginal distribution for high level because I wasn't getting specific on the other types of the other variable there. Let's go ahead and go on to the next one. What is the probability that a manager was at a medium level or went to a public college? So that means the probability of medium or public. Now, since there's no givens, I know that my total is going to be my grand total. All right, it's going to be 3265 underneath. Why do I know it's 3265? It's the same grand total for everything. So who am I interested in? Well, you have public or medium. So here's all the public people, right? And then I also want to catch this one little medium over here. Be careful so that if I just add these all up, 75 plus 962 plus 732 plus 794, my decimal value is about 0.785. Voila. So this was an OR. Now, another way I could have done it is I could have added probability of medium. I could have done probability of medium plus probability of public, right, minus probability of medium and public. And that would have worked as well. And it should have given me roughly the same answer, figuring all of that out. So what does that formula do? What it does is it adds this probability here, and it adds this probability here, but it subtracts out the double counts right there, the 962. Okay, so let's go ahead and do the OR probability on this problem. What is the probability the manager was at a high level or went to a private college? So private college, that's this column right here, but we also want to capture the high level. So again, I'm going to do this one a little different. I'm going to say probability of high level, high, or private equals probability of high plus probability of private minus this little overlap here, privé, whatever, minus probability of high and private, right? There we go. So probability of high, I can just say, oh, high is 182, right? 182 divided by 3265. Plus probability of private, there are 1,496 that are private out of 3265. And then just subtract out that overlap where we're double counting, 107 over 3265. And guess what? When you punch all that out, you should get 0.481. Voila. And or you could have just added these four numbers together, and that should be what you get when you get these numerators put together. So that's the OR probability. Couple different ways to do it. You can individually count, making sure you don't double count, or you can use the formula and make sure that you subtract out the double count, which is the 107 in this case. On to the next problem. We are going to do, what is the probability that a manager was at a medium level and went to a public college? So this one's actually the easiest. This one is this section right here. It's that 962. So it's kind of, remember, it's the thing we subtracted out. So I'm going to say probability, medium, and public. And that says public. There we go. And equals. So there's only 962 that fall into both categories. 3265 is still the grand total. My stylus is getting a little wonky. There we go. Come on back, stylus. I was doing so well. Probably because I was writing bigger. 3265. Yeah, that's what it likes. And we get, when I put in the decimals and the calculators, 0.295 or 29.5%, if that's what you like. All right, so that's it for that side. What is the probability that a manager was at a high level and went to a private college? So again, guess what? It's that same number we were looking at here, that 107. So probability of high and private equals, well, how many were in the and? There were 107. 107 in the and out of 3265, which after you put the decimals in the calculator, you get 0.033 or 3.33%. Okay, so that's the front page. Well, almost. Let's do the last problem. And we'll do problem 4. What is the probability that a manager went to a public college given they're at a medium level? So when it says given they're a medium level, you can just focus on everything that's medium. We're going to ignore everything else. The only numbers of interest to us are 962, 794, and the total 1756. So what is the probability of public given medium? So what we're going to say, given their medium, the easiest way to do these is to just write down the total, 1756. That's how many are in our little world that we circled there. See that given right there? Right there. That's 1756. And of those, how many are public? There are 962 are public. Where did I get that? It's right up here. That 962 are public because that's our public column, right? And Then I go ahead and do the decimals, and I get 0.548. Now let's go on to this side. What is the probability a manager went to a private college? Probability of private, given they are at a high level. All right. So how many? We're only interested in high-level managers. We don't care about the others. Very cruel, isn't it? So let's see. Oh, that's interesting. I sort of did the same. What is probability? Yeah, given that they are a high level. So this one I'm doing a row again. All right. Maybe I should change it up to say what's the probability they're at a high level given they went to a private college. But oh well, so it is what it is. So the total for high is 182. And how many of those are private? 75. Oops, is that right? 107. 107. Yeah, it's not 75. It's 107. 107. And when I do my decimal thingy, I get 0.588, or about a 58.8% chance. Let's go on to page 2. Page 2 is going to be a little more complicated. I'm just going to draw one tree. It's the same tree for both sides. All right. So you will have a quiz question very much like this. So I'm going to start on this left side, and let's just focus here. After each software change, developers run tests to check whether they have introduced bugs. Suppose that after a software change, the probability the software has a bug is 0.1. Yeah, 10%. Pretty high, actually, but that's probably it. So I'm going to make a little note. Probability of a bug equals 0.10, and B equals bug. Okay. If a software has a bug, then the probability of testing positive is 0.95. So let me go ahead and do that in a different color. So 0.95, that is the probability of positive given a bug, right? But if it has no bug, then it has only so it could be clean, and that would be the probability of testing positive given no bug, or you could say bug prime or BC. All right, any way you want to do it. All right, so let's start drawing our tree. So if I were to start drawing my tree, first of all, I need to know if the software has a bug or it doesn't have a bug. So it's bug or bug prime. So my software starts, I do my changes, neither it has a bug or it doesn't. Now we do know these numbers. We know them because we said the probability of a bug is 0.1. So I'm going to put a 0.1. I don't need really the 0. So the probability of it not having a bug is 0.9. 1 minus 0.1 equals 0.9. That's where we got that number. Okay, so then we're going to test the software. So let me go ahead and add onto the tree. And it's either going to test positive or it's going to test negative. Same thing here. This is either going to test positive or it's going to test negative. So what is the probability of if it has a bug? So see this blue condition right here? That's for the top part of the tree. So if it has a bug, the probability it will test, if it has a bug, it's not the blue part, it's the green part. Let me go ahead and get that right. So if it has a bug, it has a 95% chance, 0.95, of testing positive, right? And then it has a 0.05 of testing negative. So if it has a 95% chance of testing positive, then it has a 5% of testing negative. Now let's get back to the blue. The blue is when it doesn't have a bug. So only 1% of the time should it test positive, 99% of the time it should test negative. So I'm going to go ahead and multiply out all these branches, even though I don't need them all. So this is the incident of probability of a bug and positive. So if I multiply both of these numbers together, I get 0.095. So the way we do it is we go across the branches. So we go there, right? This bottom one would be the probability that it has a bug and it tests negative. So that means it would be the 0.1 times the 0.05, let's see if I can fit that in there, equals 0.1 times 0.05, which is 0.005, right? Okay, so those are the two outcomes if the software actually did have a bug. All right, but it doesn't always have a bug. Only 10% of the time it has a bug. Although you might say, oh, that's a lot. Okay, now 90% of the time the software should not have a bug. So what's the probability it doesn't have a bug and it tests negative? Well, that is going to be 0.9. Let me go ahead and erase that so it's not quite so hard to read. And I'll make this just a touch bigger. 0.9 times, so you get the 0.9 here, and then the 0.01. So you should get 0.009, right? That's that probability right there. Then finally, we have probability that it, oh, did I say negative there? Why did I say negative? This is positive, positive, positive. Because we're coming off the positive branch. It doesn't have a bug and it tests negative, which is hopefully most of the case, right? So it'd be 0.99, 0.9 times 0.99, which is going to be a big number, 0.891. Not a super big number, but on a probability perspective, it's a big number. All right. So it's just an FYI. It's the same tree for both sides. All right. I just have different questions. Same tree. For both sides, just for your reference. So you should be copying the same tree down for both sides. All right. So it's a good idea. It's a good idea to make sure all probabilities add up to 1. Always a good idea. Let's make a note of that. All right. Do they add up to 1? Well, if I add up 0.095 plus 0.005 plus 0.009 plus 0.891, guess what? I get 1. So that's good. Okay. So, and just as a general rule, in case you didn't figure it out by now, to calculate these probabilities, multiply the branches from left to right. Okay, so that's some good idea. Now, some other notes on the tree. Branches are starting at the same point must add up to 1. So, for example, if I look at these branches starting at the same point. Oh, let me make this bigger so I'm not so messy. Starting at the same point must add up to 1. Okay, so that's how you get that. So let's start on the left. What is the probability that the software has a bug and tests positive? Well, here's the good news. We already calculated that. It's go away. Probability of a bug and positive. We already said it's 0.1 times 0.95. Pretend you can read that, which is 0.095 or 9.5%. All right. What is the probability that software has a bug and tests negative? So probability of a bug and negative equals, well, there it is. I can kind of see it on the left corner. I'll just copy it off. It's 0.01 times 0.05, which is 0.005 or 0.5%. So that's number one. What is the probability the software tests positive? So now this is an interesting thing. It's not asking you about the bugs. So the probability the software tests positive, there are two ways to get there. There is the top branch. These are all testing positive. Plus this bottom branch, we have some bug-free software that's still going to test positive. So the way I'm going to write this down, probability of just positive. Well, there are two ways to get there. There's a probability of a bug and positive, or maybe the software is clean, and here we go. So it has no bug, but it still tests positive. So what I can do is just add those values, bug and positive. If we look up there, it's 0.095 and 0.009. And that's a decimal right there. 0.095 plus 0.009, which gives me 0.104 or 10.4%. Okay, so there you go on number 2 on the left side. By the way, this is partner B side on the left, because you switch sides when you flip the paper over, just an FYI. What is the probability that the software tests negative? So similarly, probability of negative, there are two ways to get there. Either I have a bug, but it tests negative, or I have clean software, no bug, right? And it tests negative as it should. So what is the probability of software has a bug and tests negative? Well, we figured out right there, it is 0.05. And then we're also looking at this other negative one right there. So we're just going to add those two up. So we got 0.005. And then we add 0.891, which is 0.896. Or 89.6%. And we're almost done. Given that the software tested positive for a bug, what is the probability it does not have a bug? So given that, so the given is positive. So we know it tested positive. Hint, there's a reason I had you calculate number 2. All right. But we want to say there is no bug. All right. So that's going to be the probability of no bug, but it tests positive, I should say, divided by the probability of positive. Where did we get this? From the formulas that we went over last time. It's from your math chart. So it's 0.009 over 0.104. Pretend that's an O, 4, which is roughly 0.087 or 8.7%. Okay. So that's how you do the given. Make sure you put the given in the correct slot. Remember, the given goes in back and on bottom. All right. So it's on, kind of reminds me, the way I remember the order is that whatever's on this back end here goes on the bottom for sure. All right. And they both sort of go on top. So last but not least, what is the probability it doesn't have it? Given that a software test is negative, what is the probability it doesn't have a bug? So probability of no bug given negative. So that's going to be the probability of no bug and a negative over the probability of a negative, which would be probability of no bug and a negative is 0.891 Probability of a negative, we said, is 0.896. So when you divide that all out, you get 0.994 or 99.4% probability. So that means, so if a software tests negative for a bug, you're 99.4% sure it doesn't have one. So it's a little different than the numbers you were looking at given in the problem. And that's pretty much it for this review. Good luck on your quiz.